All right, in example 3, we're going to find the area of the region in the first quadrant, bounded by the curves y equals x squared, y equals 8x, and y equals negative x plus 7. I'm going to do a quick little sketch of this on my calculator just to help me see what this looks like. We've got y equals x squared, and we've got y equals 8x, and we've got y equals negative x plus 7. None of those were terribly hard to graph by hand, but there's y equals x squared. Okay, so we've got this region in the first quadrant, and I'm just going to quick sketch it up here. We've got the parabola, and we've got y equals 8x, pretty steep relative to the parabola. And we've got y equals negative x plus 7. And y equals x squared. And here's our region right in here. Now, what makes this problem a little bit different from all the other problems we've done up to this point is that this region, the boundaries change. What curve is the boundary changes as we move from left to right on this curve. So if you look at the region and start all the way at the left-hand end, and you'll go over to right here where these curves intersect. To the left of that line, y equals x squared is the lower boundary of the region, and y equals 8x is the upper boundary. So we're going to use those two curves to find the area of that portion of the region. And then to the right of that red line, y equals negative x plus 7 is the upper boundary, and y equals x squared is the lower boundary. So we'll use those two curves to find the area of that portion of the region. And then we'll take those two areas and we'll add those together to get the total area of the region. So that's going to necessitate two integrals for me here in order to find the area. So I'm going to take the integral from, we'll find the limits of integration in a minute. For the stuff to the left of the red line, 8x is our upper curve, and x squared is our lower curve. So we're going to integrate 8x minus x squared. And we're going to add to that the integral of, and then to the right of the red line, the upper curve is negative x plus 7, and the lower curve is x squared. So we're going to set that up as our second integrand. And now we just need the limits of integration. So we need all of the intersection points. We need to know the x value of this point. That's going to be the lower limit of integration of the first integral. We need to know the x coordinate of this point. That's going to be the upper limit of integration for the first integral and the lower limit of integration for the second. And then we need to know the x coordinate of this intersection point. That's going to be the upper limit of integration for the second integral. The first one's pretty easy. That x coordinate is 0. And then we need to know where y equals 8x and y equals negative x plus 7 intersect. I'll do that from my calculator. Again, not that it's difficult to do this by hand. I'm just having a lazy day. All right, so we'll use y equals 8x and y equals negative x plus 7, and where they intersect. And that's at 7/9 is the x coordinate of that intersection point. So that's going to be our upper limit of integration for the first integral and our lower limit of integration for the second. And now I need to know where the parabola and the line y equals negative x plus 7 intersect. So I'll go ahead and do another intersection. And I want the parabola, and nope, not that one. I want y equals negative x plus 7. And we want them to intersect right there. 2.1925824. 2.1925824. And so we've got this first integral which gets everything to the left of the red line, and this second integral which gets everything to the right of the red line. We add those two together and it gives us the total area of the region and I'm going to go ahead and integrate that. I could integrate it by hand, but I'm going to go ahead and use the numerical integral. So we'll take the integral of 8x minus x squared. Oops, missed my x squared. From 0 to 7/9 plus the integral of negative x plus 7 minus x squared from 7/9 to 2.1925824. Uh-oh, what did I do? Oh. Told it to integrate with respect to x squared. And there we go. We get 6.709 as the area of this region. And there you go. That's the end of example 3 and the end of this lesson.